Welcome to Microsoft Build. My name is April Edwards, and I'm going to be walking you through this session today. In today's session, we're going to be talking about GitHub and Azure and how they're better together. Please feel free to reach out to me on social media with any questions after this session, and I'll be happy to answer. So what are we going to talk about today? First thing we're going to do is we're going to level set. What is DevOps? We have all very different backgrounds, life experiences, and cultures. So we're going to level set here and explain what DevOps is, what it means to us, and bring that through in this entire session. The next thing we're going to do is we're going to talk about securing our development lifecycle, how we can do that with Azure, the tooling we have in GitHub, and we're going to talk about development in GitHub, integrating these tools together. Then we're going to talk about GitHub Enterprise and the advanced security features that are included with that. And then we're going to go and secure our workflows. So we have a couple demos in this session. So hang on, we're going to go for a ride and we're going to deploy some code using GitHub into Azure. So let's talk about what is DevOps. And if I were to ask each and every person out there that's watching this right now, I would get a very different answer. Why? Because we have those different backgrounds, we have different experiences, we have different job titles. So for all of us, DevOps means something different. But here at Microsoft, we have a definition of DevOps. DevOps is the union of people, process, and products to enable continuous delivery of value to end users. Now, I want to focus on this word value because it doesn't matter if you're shipping hardware, software, infrastructure as code, or anything. We need to align our value within our organization so that everyone in our company and in our organizations are delivering to a single goal. We need to incentivize our teams to work together. Now, think about you and those of you watching that are IT pros or in the operational space. You're there to keep the lights on 24/7. That's how you're incentivized. And if you have a server down scenario, you might be out of a job. So we're always trying to keep those things on 24/7. Now, as a developer, I'm incentivized to push code and to push out features. And I might have some weird OKRs that I'm measured against in my organization. But regardless, my development teams and my IT pro teams are incentivized differently. We're not aligned to the same values. So we need to deliver that value to our end users, no matter what that is. So why does DevOps matter? Why do we even care? Well, the DORA report from 2021 shows that high-performing DevOps organizations have 973 times more frequent deployments. Some organizations deploy every single day or every hour. That's what works for them. But we also know these high-performing DevOps organizations have over 6,500 times faster commit to deploy. Now, we also know that we can recover from these incidences over 6,500 times faster than previous to before. And we know that we're going to have a lower change failure rate. Now, the bottom line is our companies want us to have faster time to market and increased revenue. Now, how many of you during the lockdowns that you may have experienced ordered a Domino's pizza? You know from the beginning of that order to when it's delivered, you can track that order all the way through. Think of the Ubers of the world and all the different taxi organizations that are like Uber, maybe where you're at locally. They're delivering that end-to-end product for the end user. And the local taxi companies are struggling to keep up. These are two great examples of high-performing DevOps organizations, and that's why it's important. So we have this term in DevOps we call shifting left. Now, let's think of doing things early and often. And we want to fail fast because the cost of doing things in production is over 640 times more than doing these things in the development and the code stage. Now, we know that 85% of the defects introduced in our code are in that coding phase. So we need to find it at the inception of that code, not when we've pushed something to production. But we've all been there. We've been under time crunch and we got to get something delivered out the door. And someone is standing over your shoulder and going, is that done yet? And we've all been there. But we also know that 95% of cloud breaches occur because someone's made a human error, such as a configuration mistake. Now, this is according to Gartner, but true. We can probably all look at some of the breaches that we've seen out there today and find that some kind of human error, manual intervention caused that breach. So we want to look at secure software development with DevSecOps. We have tooling that will enable you in GitHub and Azure to easily kickstart your organization and scale your DevOps and DevSecOps practices with a unified solution. We want to be able to embrace those DevOps practices in our software delivery, but also look at maybe how we can remove those bottlenecks in our organizations. Now, there's a massive human factor, and the people change is the hardest thing to change. But we can look at how we can use this tooling to help our teams deliver more. So how can we deliver our apps more securely with a unified solution from Microsoft? So let's talk about the development phase. Where we write our code matters. Whether we're using VS Code, Code Spaces, or Visual Studio, we should be putting that code somewhere, like a GitHub repository. And then from there, we should be deploying that code, whether we're using Azure DevOps or GitHub Actions. We then have to look at some kind of advanced security to help us look at our repositories and where our code sits. Because remember, we want to shift left. Then how we deploy that code into Azure will matter. Then we look at the SecOps part of our organizations where we've deployed something and always that security person comes in the room and goes, excuse me, that isn't secure enough. And we have to redo it, or we're in production and we've already found these breaches or holes in our code or holes in our infrastructure that we've deployed. So we need to find ways to automate this. So we can use the SecOps part of this process to look at, are we using things like Azure AD as the backbone for authentication, and maybe how we're using things like Azure Monitor to tie everything together? Because remember, DevOps is a process. So we want to make sure we have the full end-to-end lifecycle. So where does security fit into this whole lifecycle? How do we get it into our code? Let's start with the fact that security starts when your developers clone your code. So we have to look at when that code is cloned, how we secure things like our workstations, which IDEs we're using, where our code's actually sitting. Is your company's code sitting on someone's machine, or is it sitting on a file server somewhere else? How is it secured? But let's look at where that code is cloned to and how it's then secured. Then are we using processes before we commit our code? Are you doing things like maybe peer reviews? Are we looking at things like VS Code to maybe look at our code and using things like dev containers? Are we using branching strategies and pull requests properly? Any kind of pair programming to help us find those code flaws before we submit that code. Then when we commit our code, we have to look at that commit stage. We need to use things like static code analysis and unit testing to help find that when we build our code and compile it. Then when we go to deploy our code, we look at things like infrastructure as code, et cetera, security scanning and cloud configuration. We can do all sorts of things with infrastructure as code testing, unit tests, functional tests, unit tests when things are in the cloud. But then most importantly in that DevOps process, we need to look at operate and monitor. Are we hooking in the right monitoring tools to get that feedback? So when we start our next pre-commit cycle, we have that information to make that process better each and every time. So remember, if our code is starting when we clone it, where can we work? We need something that's fast, standardized, and secure. And many times when I work with organizations, they can't use some of the IDE tools locally because their machines are underpowered. How many of you have been there when you get ready to start on a project and you have to clone your repo, you get everything set up on your machine, and it takes days. Maybe you're waiting on access to something, or you have to get all the right tools for your project installed. That's where using things like dev containers is really helpful. But by automating your developer environment by something like GitHub Codespaces, you can have those really fast cloud environments ready to go on the fly. We want to increase developer innovation, and we want to initiate these processes within our organization and help our developers to achieve more. We need to tailor our environments for each developer team, and maybe each project or each repo needs its own code space or its own dev container. We want to empower, not inhibit our developer productivity within our organizations. And it's really hard. Sometimes if you're working on multiple projects and you have to download and get that code into your Git repo, from your Git repo onto your machine, you have to do a lot of context switching. We want to reduce the amount of manual tasks and context switching that our developers have to do. If they can spin up an environment in which they can write their code first, where it's all secure, standardized, and fast, we can get to writing code, reduce the context switching, and also reduce more human error. Now, we also need to secure our pipelines and our infrastructure. There's been a couple instances that have been in the news in the past few years, and some of you may recognize some of these instances. So we have Capital One that had a misconfigured firewall. Someone deployed a firewall in their environment and allowed backdoor access to their servers. And the breach occurred for months before they even knew about it. Why? Because they didn't check their code and their configuration before it went to production. And they had no monitoring in place to find that breach. So their time to acknowledge the breach and remediate it was months on and having a lot of impact on data that should not have been accessed. We also have Equifax, where they had a web portal hacked. Passwords were stored in plain text, and there was a lot of patching that wasn't done on their production level environments. Now, we've all done it. We've been in a rush. We put a password somewhere in a plain text file and say, oh, we'll deal with that later. How many times do we forget to remove that password, or is it somewhere vulnerable? So we need to ensure that development security alongside that developer velocity. And we need to make sure we have some kind of centrally governed and secure engineering system. We need controls that so only trusted and approved and authorized pipelines can run. And we need to enforce those supply chains. We need to ensure that our development from non-trusted pipelines will be controlled by denying those production deployments because we don't want them in place. We want to prevent build tampering because we've all seen it and we don't want that to happen. We need to also prevent unauthorized access to our packages and our repositories and also our production infrastructure. So when we secure things, we can look at things where we can use GitHub Actions for Azure. We can accelerate our delivery through automation. They're simple and they're easy to use. And there's a global community of open source actions that you can use. You can automate workflows. What kind of workflows? Pretty much any workflow. You can shift that security and that compliance left. You can start secure and you can maintain that security through your development process, enable you to deliver that operational seamlessly and accelerate that developer velocity that we keep talking about. But I want to talk about GitHub workflows. They're not just CI/CD. While yes, they allow you to create a repository to respond to any kind of GitHub event, they literally can respond to any kind of GitHub event. So yes, you can use them for CI/CD to build and test your functionality, but you can use them to literally automate anything. You can use an event or use a schedule to drive that deployment. It has built-in secret shares. They're easy to write and to share, and they're modular and they're completely reusable. And they also run on Linux, Mac, and Windows runners in the cloud. So it enables you to test against any kind of OS and platform. So let's get started into looking at how we can enable our developer velocity and look at how we can use those GitHub features to deploy our code. So here we have our GitHub repository. We have an application that we would like to make some changes to. So all of our code is sitting in this GitHub repository, and I've been asked to make some changes to my code. Now, let's look here at an issue that's been opened by our marketing team. Our marketing team has asked us to change the front page of the website for an upcoming event. Let's have a look at the actual website. It just says welcome. It's a really simple website. It uses JavaScript on the back end, nothing crazy, really easy to build. So hopefully we don't break it. So the marketing team has asked us to make this change to our website, and they've opened up a GitHub issue. Now in this issue, we can completely track everything from beginning to end. So in the issue, I can assign myself. I can also assign someone else in my team. I can add a label to it. I can also add it to maybe a specific project. Maybe this application is part of a specific project or a milestone. The other thing I can do from within the issue is create a branch or link an existing pull request. So if somebody opens an issue that maybe is already a known issue with a pull request, we can link it from here. So I can create a branch and start working right away. Now, how do I change my code? If I go back into my repository, very commonly, we would clone our GitHub repository. And again, we talk about this problem when we go to clone our repository, it takes time. And maybe we need access to certain packages and tooling and things that take a lot of time for us to get spun up on. Now, if I'm in my GitHub repository and if I hit period or full stop, I can open up the GitHub web editor. So this is going to open up a very simple web editor for me from GitHub, and I can make changes to my code in my repo. Now, a little bit of warning, this isn't really secure. It is a fast way to make changes, and it means I don't have to spin up an environment. I don't have to work with my VS Code, or I could just work from pretty much anywhere in the world. The problem is this doesn't import my extensions, and I can't run and debug my code. So I tend to only use this for things like maybe changing a README file or something really simple that doesn't maybe have to go through my development process. So instead of cloning my code locally, I'm going to spin up a GitHub code space. Now we have a couple options here. I can create my code space on my main branch. I can also click on this and create and configure a code space. So we're going to do that from scratch. When I go to create my code space, I have the option to already use my main branch or go to another branch. I've already created one for my issue with my issue name, or we can use, any other methodology that works for you and your team. Now, if you have dev containers configured, you can import that here. I'm going to use the default one for this one, and I can choose my region. So if I'm sitting in the US, I can spin up in US. I'm actually sitting in near Europe West. So for me and my data residency, that's what works. I can also choose my machine type. For what I'm doing, 4 cores, 8 gig of RAM is totally sufficient. So I'm going to go ahead and click the button and create my code space. As it creates my code space, I can actually open up the code space in VS Code Desktop. So I have that ability. I could actually open up my code space on my web browser and in VS Code and make my changes and see the changes simultaneously take place in the other one. But for sake of time and getting everything ready, I'm just going to spin up this code space. So we can see as the code space is loading, all my extensions are starting to load in here. The other cool thing about a GitHub code space is that I can turn on live share. So if I'm pairing up with one of my colleagues and making this code change, I can share my session out with them, or I can join someone else's session. So whether my colleague is using Visual Studio, VS Code, or GitHub's code space anywhere else in the world, we can pair up and work together on our code. Now we can see all my extensions loading up over here. We can also run and debug our code from here. This is a full VS Code experience in a web browser. It is fully secure, it's fast, and it's scalable so that anyone on our team can spin this up and make some code changes. Now that I've spun up my GitHub code space, I'm going to go ahead and switch from my main branch onto my working branch, which I've called Scuba Ninja-issue 9, just because it matches the issue that's been opened so I can trace it. Now, also in my code space, we can see that it's open up to the live share extension. I can go ahead and share out my session and pair program with a peer and work together on my code. Now, I can also join another person's session and pair up with them. This is great if I'm working remotely in other parts of the world, or maybe I'm traveling and don't have access to VS Code, but I can quickly get into someone's session without spinning up VS Code or Visual Studio. But whether my colleagues are running Visual Studio or VS Code, or in another GitHub code space, we can all work together with LiveShare, no matter what they're using, because it'll work across all 3 different IDEs. We can also go up here and see that we can run and debug our code here. So all of our extensions on this left-hand side are enabled, where they weren't in the web editor previously. So the GitHub code space gives us that full environment, and we can import our own working dev container for every project that we're working on. So let's go to our code. I've put myself on the correct branch. I want to go ahead and make a change to our website. So the issue that was opened by our marketing team was that they want us to change our website for the event. So we're going to go ahead and do that. Now I've made changes to my code. It automatically saves my changes, and I can go ahead and push those up to source control and commit that. So as those changes sync across and I'm working from this new branch, I can actually open up my PR straight from GitHub code space, but I want to go back into our code, look at our pull requests, and we can see that I've pushed this code across. So we've pushed our code up into our GitHub repository on our branch. We're going to go ahead and create a pull request. As I create this pull request, I can change my website. I can also link it to my issue by just typing in the # and it will pull up the issues I have listed. So I'm going to go ahead and list it to issue number 9. I can add reviewers here. I can assign anyone I want on my team. I'm going to go ahead and assign myself to work on this. Again, we can add those labels, those projects, and those milestones, and I'm going to go ahead and create that pull request. Now, as I create this pull request, it's going to kick off a couple of workflows. So let's go to those. So the first workflow it's going to kick off is our code QL workflow. We're going to go over that in a minute. But the other one it kicks off is our change to website against our branch. So I want to go ahead and view this workflow file and go over it with you. So anytime I make a pull request, it's going to kick off this workflow. And in that workflow, we're going to go ahead and build our image out. So what we've done is we've containerized this application so that we can literally deploy it anywhere, whether we want to put it into a container app, an Azure web app, or in Kubernetes, etc. So we're going to go ahead and check out our code. We're going to go ahead and log into the Azure portal and notice that I don't have my credentials here on display. I've put them in as a secret. I authenticate into Docker, which is my Azure Container Registry, where I'm keeping my images. I'm going to build and push that Docker image, and then I'm going to scan this image here using Microsoft Defender. So not only am I looking at my source code, building my image, I'm putting my repository into Azure, I'm putting my container into Azure, and then I'm scanning it with Microsoft Defender for any vulnerabilities. And then I can send all those logs to Application Insights. So while that's running, that's also going to spin up our development environment in which we're going to deploy to. So while that is running, let's go back into our deck and talk about some things there. So in that demo, we talked about a lot of things that may be really new to you. So things like GitHub Enterprise. GitHub gives you this flexibility to deploy a fully integrated platform in the way that makes sense for you and your organization. So we can automate everything with actions. Like I said, they're not just CI/CD. So yes, they can do continuous integration and continuous deployment and continuous delivery, but it allows us to look at ways we can do things in the cloud or on-prem. We can also shift our security left and our organizations left with advanced security code scanning and secret scanning. And we can have rapid and effective collaboration with GitHub code spaces. Now, as I showed you, I spun up that code space really fast. We deployed some code and it's deploying as we speak. But let's talk about that deploying of our code. When I committed that code, I could have made some changes. I could have accidentally uploaded a password or a secret that should not have been known. Now, when we went through that workflow file, you saw that I put a lot of those secrets in that workflow into GitHub secrets. But maybe I put a secret into something else, or I did something else in my code that isn't right. Because again, 85% of those code issues happen when those issues in our code happen when we're writing that code. So how many of you remember back to 2017 where Uber had a massive attack? A couple hackers got into the GitHub repository that Uber was using to write their code. Now, this was a private repository used by their software engineers. Now, in that repository, those attackers found login credentials to access data on a cloud account that handled computing tasks for the entire organization. It was a massive archive of rider and driver info. So everyone was exposed, unfortunately. Now, this affected 57 million users. And Uber had to pay over $100,000 to have the info deleted. Why? Because they put their passwords in plain text in their GitHub repository, in a private repository nonetheless. We don't want to put passwords in that repository, and we especially don't want to deploy it to the cloud. So this wasn't a cloud provider's fault, but a software engineer's issue that wasn't caught. So how can we prevent it? So GitHub has in their advanced security things like CodeQL, where your code is treated as data. And it scans your code as it's created to find vulnerabilities. And I'm going to show you my CodeQL workflow. So that workflow is going to run while our code is being packaged and deployed so they can find any vulnerabilities within that code. Next up, we have Dependabot. Dependabot allows for dependency scanning in public repositories and private repositories, and it automatically opens up a pull request for your team to see and will suggest fixes and remediations for your team. And it will grade it based off of low, medium, and high. And these are dependencies within your code. So maybe you're using an NPM package that's out of date. Those are issues in your code. And sometimes that's hard to find, especially if you're using a lot of different packages within your source code to deploy your applications. Next up, we have secret scanning. And secret scanning will scan those public and private repositories and will notify the admins when those passwords are found. So that Uber breach could have been prevented when the right tooling was put in place. So that's exactly why GitHub Advanced Security has these features built in to secure your code, because as developers, we do make mistakes. So we talked about securing our GitHub Actions workflows. Now, again, we want to shift from that manual management of our workflows and that operation of IT environments to seamlessly enable automated IT management that is controllable, collaborative, and repeatable at scale. Because that's the big thing. We can do it once, but can we do it many times and for a larger organization or for growth? So a lot of times we talk to organizations about top actions for compliance management, because compliance is key. Because we don't want to deploy our code, have someone tap on our shoulder and say, this isn't compliant, and we have to revert everything. So we can orchestrate policy integration. So we can manage Azure policies as code straight from our GitHub repository. And we can scan containers. So I've set up Microsoft Defender that will scan all my all my images that I put into my Azure container registry, which I'll show you in a minute. So then if we containerize them, so then when we deploy them, we can scan them for any vulnerabilities into any kind of web app or Kubernetes cluster before it gets deployed, and we can flag it. And we can also manage our secrets using Azure Key Vault within Azure or secrets into GitHub Secrets. So let's look at this reference architecture of what we're deploying today. Our code is sitting in our GitHub repository. We're using our inner loop with our IDE. We're writing our code. We're testing it, debugging it in that inner loop style. We open up our pull request against source control, and we deploy that out for our build and release. We build it, we test it, we scan it, and then we deploy it. But we're using everything as code. So in this repository, I'm deploying my infrastructure, which is Azure Web Apps, as infrastructure as code using Bicep. I can hook an Azure policy to that and treat Azure policy as code. And I'm deploying that all with a GitHub action. Again, this is all code from beginning to end. And I can use those built-in tools to look at that. Then that feedback loop will give us the monitoring around it. So I can hook an Azure Monitor on top of not just the Microsoft Defender product. And we can come around and look at maybe any issues in our code before it goes to production. And we can look at the policies and compliance. So let's go back and look at how everything's deploying. So we can see that our GitHub repository, we've opened up our pull requests, and there's a lot of things going on, and there's some checks. So let's go in to see what's happening. So when I kicked off my PR, it created a build. So remember, we talked about it building and pushing our Docker image. We created and deployed our container to Azure, and we deployed it to test. So we deployed a development environment, we deployed to test. We can see it's popped out a website for us. I'm going to go ahead and click on that now. So we can see that our changes have gone through to our test environment. I want to go ahead and look at this, make sure it's okay. It's exactly where I want it to be. And then I'm going to go ahead and give it a review for the next stage. So I want to deploy to our staging environment over here. So I can go ahead and click on review deployments. I tick the box and I can say, okay, to deploy. I can approve this deployment. So while that's deploying, let's look at the security features that we spoke a lot about that's built into the GitHub platform to enable us to deploy to Azure. So if I go into the settings of my repository, I can see that I'm using secrets. Now, we looked at that workflow file, and we noticed that there were secrets involved. Now, I have different environments. So how did that work? Well, I have a dev environment. So anytime a developer builds and pushes their code, it goes into a dev environment. Then we just went into test, and we just approved it into our staging environment, and now we're going into production. So I have protection on both staging and production because I want to protect those environments from automatic deployment. So I require reviewers. Now I can add a team of reviewers, which is best practice, and then they have to review it before it goes on to the next phase. They can check, make sure that all the processes went through as they should have. And within each of those environments, I can set up those protection rules. I can also set up passwords. So in my staging environment, I could maybe put the location, maybe in a different environment for a different location for the physical environment. I can change the resource group name, and I can use the name of my web app and make sure it's hidden and not exposed externally. So I've used environments to segment out my actual deployment environments for my Azure web app. I've used secrets to hide all my code. Now, I want to look at code security and analysis because I talked about all these things that we have enabled, but there's quite a bit. So we can see that I've enabled them all in my repository. So I have Dependabot alerts. So again, my code is treated as data, and it scans it for those dependency issues. So if there's any code packages that would flag up in here, I'll see it. We can also see that I have code scanning enabled and secret scanning. So if I go to my security tab, I can get a little bit of a good overview of what's going on. I can set up an actual security policy for my team. I can look for Dependabot alerts. Now, thankfully, I don't have any Dependabot alerts. Now, I'm going to go to my code scanning alerts, and there's none here. So it looks like I've pushed some good code. Now, I can also see in my code scanning alerts that it's last scanned a few minutes ago when I pushed that code up. We can see the pull request number, and we can see that the code scanning alert ran a workflow called CodeQL. So if I go ahead and open that, we can see this ran. Now, the CodeQL is going to run against every single PR that I open. So the first thing that's done is analyzed my code. So it's analyzed my code. It's automatically picked it up that I was writing my code in JavaScript. If I were to use another language like C#, etc., it would pick that up. Now, when we are in this CodeQL workflow, we also see that it's failed. It's failed on my container scan. So this is where I can set up a policy to stop my deployment. I wouldn't let it go to production, obviously. I can see that I have one high vulnerability, no critical, one warning, and 2 infos. So I can look at these and have it look further into this, open up a GitHub issue and look at the quality of my code and what's in my container scan. So we can see that I have container scan issues here. I've tracked it with the SHA number from the release, which is here. We're going to go ahead and go into our Azure Container Registry. This is the repository that I'm using for this. And we can see the exact number is here. So this FE624 matches up exactly with the container scan result. So it has actually scanned my container with my image to find those. I can go dig in further into Microsoft Defender and look at how to remediate it. So I can see what resources are affected here. I can see that I have an unhealthy registry. Now, thankfully, I have a healthy registry, and I've named it App Deploy Azure. And if I click on it, it will open it up, and I can see any issues that I have. I have healthy images. So again, nothing was severe. Everything was a pretty much low or medium priority, but doesn't find any actual severity in here. So this will also scan it, give me reporting, and I can hook this into a dashboard to have that better visibility. So let's check in our website and see how it's doing. So we can see in our workflow here that we've built and pushed a Docker image, we deployed to test, we deployed to staging. Our staging deployment has deployed successfully. We can go ahead and click on this link here and see if it deployed correctly. And it has. So we've successfully deployed to all of our environments. We can now proceed to production. We've talked about a lot of cool stuff today. So I've put together some resources for you that will allow you to get started using GitHub and Azure together. We have some great resources on GitHub and Azure integration. We also have a listing for all of the available GitHub actions that you can deploy right away for Azure without having to write your own action. You can also read more about Defender for containers. And you can also replicate what we've done today in the bottom link in the GitHub repo. It's a public repository. You can take the code, spin up a website really quickly, and get started. Thank you everyone for joining today. Good luck getting started with GitHub and Azure. And remember that GitHub and Azure are better together.